All right. Well, welcome. And I'm here because of the IMPART project, and I've been doing some research with the Oculus Rift. My name is Gerard, Llorach, and I finished my degree last August, and I started working with the department with the Interactive Technologies group in Universitat Pompeu Fabra in November. So I've been doing about 7 months of research with this, and when it came, the Oculus Rift, we were very excited about it. We were trying all the demos and everything, making the pictures, uploading them on Facebook. And the thing is that some of us started to get sick when we were doing some simulations, just maybe 1 minute or 2 minutes, and we were starting to feel a bit sick. And I was like, why is that, right? So Alan, could you? Yeah.
Why?
All right, why is that? What's the main problem? Motion sickness when using your Oculus Rift. So why is that happening? One of the main theories is the sensor conflict theory. This theory states that the relation between your vestibular system, that's the one in charge of the equilibrium and changes in acceleration in your body, causes symptoms when it's not related with your visual input. So one example would be when somebody's driving and you're reading a book, so your field of vision is still, but your vestibular system feels like you're moving around. So this would be with the Oculus Rift is completely the opposite. Your view is moving, but you're still. So that's why you get sick. So what do we want? We want to avoid sickness, right? So the main problem that we found, it was when you were doing a locomotion task. Like you were moving around a virtual environment while you were seated or not moving at all. So I don't know, I didn't want to ask for a lot of hardware, so we decided to develop, try to estimate the position using the sensor that's inside the Oculus Rift. As you know, the Oculus Rift, when you turn your head around, it tracks where you're looking at. So this sensor was developed in 2010 by InventSense, and it's been widely used in mobile phones and also in drones and all kind of like this kind of carts that move when you pull forward. Yeah, segways, exactly. So, So the thing that there's many accurate tracking that already exists, like mocap or other systems that, for example, the new version of the Oculus Rift that they want to develop has some infrared lights on the Oculus itself, and then they put a camera in front and then you can dodge and move forward and backward. But they are always dependent on the space. Like usually you have a room with cameras, or you have a camera in front of you, or some others try to put a camera on yourself and then you make like some feature extraction of the space. So our approach is to create a low-cost and no extra hardware required solution. So we use the system that's the IMU that's inside the Oculus Rift and no other hardware. So we didn't need anything else but the Oculus and a computer. The thing is that when these sensors were released, Google did a talk about 45 minutes about them, like how they work and what's good about them. And well, they said that it's impossible or not even try to track the position because you have to double integrate the acceleration, and usually you get a lot of drift, and you might be still, and in the virtual world you might start like going exponentially, changing the position exponentially. So how great is our system? Well, after some filtering and some work, we could track the position, but not very properly. That's why we say that it's a position estimation system, not a position tracking system, right? So low accelerations are not tracked because they are considered to be maybe errors from the measurement of the accelerometer. So usually if the person is like moving very slowly, this would be considered as an error of the accelerometer, or well, a false positive, so it would be not taken into account. And then also constant velocities are not tracked. This is because of the filtering that we applied in the system. And that's one. And well, to walk or be able to move in this environment, you have to take separate marked steps. So it will be something like this. So you walk, and then you do another one, and then you can go sideways or wherever you want. So if you want, you can show the video. It's in the desktop, yeah. So more or less it will work like this. It's not perfect, but you can move around without anything else than the Oculus. So as you see, when you walk, it moves, but there's a lot of tracking error also. Like sometimes when you move the head, it just moves in the virtual world, or you make a big step and then you go a bit backwards. You see now, I'm going to turn right and it's going to go left here, you see. Well, these environments are the ones that we did for the experiment I'm going to explain now, but we did a test with users. As you see, you only need the laptop and the Oculus. There's no constraints with the cables, and actually you can do it in every space. You just need somebody with you so you don't collide with stuff, you know. This was a 4th floor, so yeah, actually it was a bit dangerous because some people got really immersed when I was doing the testing, and I would say, okay, stop, because you have a wall in front of you, and they were like, but I'm about to get to the red point, and then walking and colliding with the wall. I'm like, okay, don't do that, because there are stairs there and you can fall over. And yeah, I got really pissed at that guy. And yeah, they didn't sign that if they got hurt, it wouldn't be my fault, so I had to take care. Yeah, so all these tasks here are based on virtual tasks that there's a lot of research on simulator sickness and this kind of stuff, so most of them are based into that. I don't know, you can see more or less how it works. You cannot like start walking or anything. It's good that you cannot run, because then you would because you're not seeing anything. You know, it was really easy to control the people not to collide with anything, and this is quite a relatively small space for virtual walking. You know, usually they use like football fields or stuff like that if you have to do a long time immersion. So back to the slides. So my next steps were to test this system. All right, we did, okay, it's working. You don't need anything. How well does it work, right? So yeah, so my next step of my research was comparing using a game controller and this system in separate experiments. So, you go on? Yeah. So, well, we had 61 users for the game controller and 55 for the position estimation system, and the total immersion was about 12 and 13 minutes. And the virtual environment was the one you saw, and one group did it with the position estimation system, and one group with the game controller. And to evaluate the sickness, we used the user questionnaires that have been used since the 80s or something like that, and everybody uses the same. So, results. With our system, we got like half of the score of the simulator sickness questionnaire. I haven't put any numbers of the scores of the questionnaire, because if you haven't done any research on that, is like having a 3, and you're like, okay, what's the 3 or what's the 4, right? So the good thing is about, can you? Yeah, sorry. Yeah. So 11.5% of the subjects had to stop the simulation because they felt so sick that they didn't want to continue anymore, and because the severe symptoms. And actually we were watching them, and some people started sweating, and a lot of people, well, some of them still felt sick in the afternoon, or maybe after a few hours of using, and it was only 12 minutes. Like, it's kind of scary, right? That if you want to develop this for everybody or consumer use, you have to be very careful. But it's very interesting also that some people didn't get sick at all. I know I was watching some guys. I always recommended to do the tasks very easily, to walk slowly and turn the head slowly and everything. And I got some people that were like running like if it was a shooter game or something. Like they were looking on the corners if there was something when they were walking through pathways, or I don't know. And they didn't get sick at all. And some people, they were doing the test normally and they got really, really sick. So I don't know, this research that has been done also shows this, that it's not like you find some person and say, okay, you're gonna get sick because you have this, 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 and this. It's sometimes I guess that people that used to play games would be less sick, but I got people that never played video games, and I thought, oh, why didn't you get sick at all? Like, I don't know. I don't know. Do you play or watch a lot of movies really close, stuff like that? And they were like, no. I was like, okay. So it's really hard to predict if the user is gonna get sick or not. And one of the things is presence. I haven't talked about this, but the Oculus Rift really brings a lot of presence into gaming. You know, you put the Oculus on and you feel like you're there mostly. And a lot of studies say that when you actually walk in the real world with a virtual head, with a head-mounted display, you feel a lot more immersed. Like you feel you're there because you're moving as you're moving in the virtual environment. But I think that because our system had really bad tracking, and sometimes you moved and it didn't track properly, it didn't happen that the users feel a higher degree of presence. So our conclusions are that the position estimation is better for if you don't want to get users sick in the virtual environment. The thing is, obviously, this is a solution when you have a space and you have the possibility to do this. And there is a valid solution. You know, we didn't know how it was going to work on the people. You know, so it was a good chance to try it with users. And this is another conclusion, that it's really important that if you want to do something with the Oculus Rift, be careful, because people might get really sick. Obviously, I don't know. I don't know if you've seen some of the demos. There's one, the roller coaster one is the famous one that you go like up and down, and that one really induces simulator sickness because it moves you a lot and you're quite still. But if you're doing a demo with the Oculus Rift, always there are like several guidelines that you want to follow. That is like, don't make hard accelerations or hard turnings, or like try to make the movement really slow and still, and the user can get accustomed to the changes in the virtual scenario. So yeah, I think that will be all. And if you wanna, the first part, the paper was published, and if you want to know how it was done, just look at my webpage. And the second one is been submitted in Edinburgh, so hopefully I will be presenting it in December, I think. So, well, thank you very much. And yeah. And have you got any questions?
I don't know, in your survey, did you collect any data of whether there's any correlation between sickness, or any of the symptoms experienced after using the Oculus versus their own history? Let's say, oh yeah, I usually get car sick, or I get sick.
Yeah.
What, did you see a correlation?
Exactly. So, yeah, there's one of the main things that also influence is if you had a previous motion history, like if while you're traveling as a passenger in a boat or a plane and you get sicker than other people, that might be one of the things that tell you if you're gonna get sicker. But usually it's about, I think some study that did it with 1,000 users, they said it's about 20% of the variance that it can guess because of this. Also, we collected data about gaming history, like if people played a lot of video games. We didn't find any correlation. And also with 3D displays, like having a 3D screen, if they play a lot, we found correlation with that, like people that used to get sicker with 3D displays used to have higher scores. Yeah, and yeah, but it wasn't like one-to-one. Like some people would say, I get average sick with this, and then they wouldn't get sick, or they would get really sick. So I don't know. Okay.
Sorry, it might sound silly, but I have an Oculus Rift at home,
yeah.
And I play during the. I think one of the things, I normally don't get sick when I try my demos or play a game, but what I found that during the winter, when it was cold, really cold in my house, I was feeling okay playing with it. I did a 1 hour straight without feeling sick, and playing Half-Life too. So
yeah.
So, but in the summer, I got really, really hot in my face, and I got sick pretty badly. So I'm not sure if this is related, but
yeah,
I
sure.
think, you know, having a really hot thing, because it gets hot really quickly when it's already hot.
Yeah.
But since I never felt sick before, I was wondering if you may want to take that into consideration as well.
Yeah, actually, in the 95, I think, and in the 70s, there's been like Army has done a lot of research on this, because they used to train, and they actually train navigators, like space navigators or flight simulators, and they investigated all the factors that can induce simulator sickness, because when they were training them, some people got really sick and were guessing this, and there's like huge list of factors, and one of them is temperature of the room. So usually it's like, when you're traveling in a boat, they recommend that you go outside and take some breeze and look at the horizon. So there's something still, and you get not so hot, you know.
Also, if I can add a point on there as well, we actually had the symptoms of simulator sickness are very similar to the symptoms of being in a hot room and being, because you actually project some questionnaires, didn't you, at the end, because people showed symptoms of simulator sickness before they even started the test.
Yeah. Yes.
You can't distinguish. A serious point. You can't distinguish between someone who's hot and sweating because it's 30 degrees outside, between someone who's hot and sweating because they're feeling sick. So,
did the participants know that the test was related to sickness?
Yeah.
Or not? They did know.
Obviously, they did to test the sickness, as he said. I did the previous questionnaire and then the same questionnaire afterwards. So they would guess, I don't know, like the title was Simulator Sickness Questionnaire, and it was like, like I don't know, there were 16 symptoms, and I don't know, because I got like a range of 22 of age or 20, and most of them were students, so most of them came running. It was a 4th floor, and they would come sweating, you know, like one of the symptoms were sweating, and they were like intense, you know. I was like, okay, this is not because of the simulators, because you came running here.
I think
So,
not sorry to interrupt, but another result that's interesting that that doesn't show in the actual formal results is the anecdotal evidence from people calling up later on and speaking to Gerard saying, I felt really sick all afternoon, and that data is not, it's anecdotal, it's not included in the Excel spreadsheets, but like it's a valid conclusion that you could be feeling fine immediately afterwards, but then 3 hours later, suddenly you start feeling sick, and I think that's
yeah, there was actually a coworker that had to drive a motorbike, and he was a bit scared because. So yeah, I didn't include that in my informed consent that they had to sign, but some others did, and it should have been included. Like if you're gonna have a long exposure, please don't drive afterward or something like that. Yeah. So.
A lot of travel sickness pills are essentially placebos, and is there any sort of research that's been done into how much of this is sort of psychosomatic and how much of it is real in a sense?
Yeah,
and
like
to kind of induce it in yourself. Like, are there any? Would you be able to do blind studies and things to?
I haven't seen any studies relating virtual simulator sickness with the medical stuff. No, I haven't. Yeah. Yeah.
Were there any dropouts when people were using position estimations?
No, like nobody got like severe symptoms as with the game controller. Like that, I was really glad of that. Like nobody said, "Oh, I feel really sick." Like with the other one, I remember where Alan was in the office when one of these guys were using the game controller, and they were like sweating me, like, "Oh God, I cannot believe I got so sick." And with the other one, no, like people would walk. What happened with the other one is that people would lose balance sometimes. Like they would walk and then make 2 steps and then go like, whoa, and do like this. Nobody fell down. Luckily, I guess. So I was always there to see if they would fall down. You know, people got really excited when they were walking. Like some people would be like trying to go really fast, and then the system wouldn't react properly, and then they would be pulled backwards in the virtual world. So that was kind of, it was really intuitive when you weren't walking the way you had to. So I always had to make a long explanation, like then, okay, you have to walk like this. Not do steps like this. Or usually, like, if you put the headset on and they tell you walk, you're not gonna be like yes. You know, you're gonna be like, okay, and then see how it reacts, and that's what the system doesn't track. So you have to say, okay, you have to make decisive steps. So people would be like at the beginning maybe doing like this and saying, are you moving in the virtual world? And we'll say like no. So okay, you have to make decisive steps and then stop. Yeah. Yeah.
Does the conclusions to the moving around in the virtual space link to simulations where somebody's sitting still, and say like a pilot, where you do space simulators, the same people get sick when they're moving in the space as to when they're sitting down still?
Like I don't understand.
So if you're wearing the Oculus and you're in a seat, so you're in the same position as wearing the Oculus, and you're looking around, you get benefits of 3D. If people get sick in that, are they more likely to get sick in moving around?
I think it's moving around, and also I believe that one of the causes that induced more simulator sickness were when they were turning around with the game controller. So if you could have a simulation where they don't have to make 360 degrees turning over themselves, because usually like they have the cables connected, everything, so they cannot turn around and make spinnings. So if you could avoid that, that would be really good. I think it was because the turning of the head without moving the head, like when they use the game controller. Yeah, that one. Yeah.
What are, I guess, the future plans to try to get the step-by-step positional estimation walking to a more
accurate system?
Accurate walking pace.
Yeah, so the main problem with this was that it had to be real time. Like there's been a lot of, probably you know, there are like step trackers that you walk and they say, okay, you've done, I don't know how many kilometers because you've been walking, right? So accelerometers, the accelerometer inside the Oculus Rift is a low-cost one. So there are ones that maybe cost $500. So I don't know if they're gonna integrate that. Probably you can like put one on top of the Oculus and then try to do that. But the main idea of the project was to just use what's inside the Oculus. So yeah.
So just more data points would probably just help.
Yeah, somebody asked me that, and I haven't really tried, and I haven't seen any research done on that. And it might be useful, you know. Usually, maybe put 3 or 4, and then make, I don't know, some filter that puts them all together and tries to estimate the error. But you always, it's really hard when you double integrate the acceleration, because you always like imagine that you get a 0.1 error, then it means that you have started accelerating some direction. Then that means that velocity is going to grow linearly, and position is going to go exponentially. So it's really dangerous, you know.
Yeah, because at E3, like I think virtual reality headsets were the theme of this year's E3, and there were even had some where you could interact with the Oculus Rift via these gloves that they had in there as well. But this was, I think, the only one that I can remember being environment independent, which is really cool. So I maybe incorporating those other things.
Yeah.